more times. Okay, today is also quiz day, so we will be posting the quiz at about 1:45, 10:45. We'll put the link in the chat, and then you can go off. New Watobians, Thursday is always quiz day, and you'll get quizzed on the stuff that we've done this week, which is compound and double angles. The quiz, yes, it's low stress quiz, because you can try it as many times as you want. It's really just to see how you're progressing and understanding. It is not something that, you know, is there to stress you out at all for whatever reason. It's really to challenge yourself and to check how you are understanding what we are doing. So you can try it as many times as you want. I think our highest number of attempts still stand at 17. So you're welcome to try the quiz more than 17 times, and maybe you'll get a special shout out from me if you break that record. And yeah, there is a time limit on it, but it's also the time is such that it's more than enough for you to be able to do it. And it's also open book, so yeah, no stress. That's why we call it no stress or low stress. Rightio, so let's get going. On Tuesday, we started off with compound and double angles. So the compound angles, if you recall, remember that on your formula sheet, you just have to identify the right one and then write it into the identity. Look for the pattern. And you can see the pattern sort of as a general idea. With cos, we always have cos, sine, and then for the plus, for the minus, it's a plus in the middle, and for the plus, it's a minus. So cos, sine, plus and minus swap around. And then for the sine of a compound angle, A plus B, that's just sine A, cos B, and then it stays the same. The sign stays the same. So for sine of a compound angle, it will always just be a plus, and for sine of A minus B, it will just stay a minus. So that's a sort of brief way to remember them, but they're on your formula sheet, so you don't have to memorize them. We can expand using compound angles, and we can contract using compound angles. So we can write it longer or write it shorter using our compound angle identity. So we did a bit of practice around that, and that's going to be in your quiz this evening. And then we just had enough time to start with the double angles. So double angle, remember, a compound angle has to do with an angle that two angles that are being added or subtracted, where a double angle is an angle being added to itself. So it's like 20 plus 20, 40 plus 40. That's why it's a double angle, because it's twice an angle. So those are four expansions for the double angles. Sine of 2a and cos of 2a. So sine of 2a only has that one expansion, and then cos of 2a. So 2a meaning it's a double angle. So anything that is being added to itself can be used to in the double angle identities. Okay, and then we have those three options for cos of 2a, and depending on your expression and which option is going to simplify it the best, that's which one you choose. So you need to practice a lot so that you can kind of see which one to use. Okay, and we did a bit of practice around that, but I think we need a little bit more. So we're going to kick off just quickly. We're going to take 5 minutes, and I want you just to do as many as you can of these questions in 5 minutes. Now remember, when I'm going to do the first one with you, just to say that, so if it's 2 sine theta cos theta, this is also on your formula sheet, so you don't have to memorize it. So that is the double angle for sine, so sine of 2 theta. So remember that if it's a theta and a theta, then your double angle is 2 theta. So here's an alpha, so your double angle is 2 times alpha. If it's 10, it's 2 times 10, so it's 20. X, 2x, 3x, 6x, and so on. Okay, so that's how you know what to write as your double angle. You literally take the angle that is already there and you just double it. Okay, so yeah, let's take till 17, 18. Let's say 17, 18, and then let's do as many of these as you can. And yeah, go ahead, post them in the chat. Some of these are quite easy, and I think some of you will get them quite quickly. But yeah, post your answers in the chat. Well done, Mohammed. Oh, Taryn also did it. Well done. Sure, there's a few Watobians who are just blazing ahead. Well done. I'm just catching up with some messages in the chat. Mohammed asked for the quiz, must we rationalize? No, no need for that. Okay, and I think that's it for the chat. Rightio. Yeah, so most of you have written your June exam on this stuff already, so I'm hoping that we are just brushing up on some skills here. Okay, so Sibusisu, when you write sine of 2 times 3x, simplify that out and make that 6x. It shows you have to simplify. The method I use, rationalized it already. Okay, so it won't, yeah, it won't make a difference. I think the type of questions that are in the quiz this evening, yeah, the focus is not so much on rationalizing. But if you can do it, that's good. And it's MCQ. It's multiple choice, all of them. So I'm sure you'll be able to find the right answer. Okay, so again, on Diswa, if you have 2x divided by 2, then you must simplify that. So 2x divided by 2 will just be an x. Okay, lots of answers coming in. Well done, everyone. Okay, hope look carefully. F is a double angle identity. We have 2 cos squared, x over 2 minus 1. So that is a double angle. Now that you are in matric, you can be guaranteed to have lots of these in your tests and exams from now on. Hardly any of the questions will not have double and compound angles in them. So practice recognizing them. F is cos of x. Yes, nice. Okay. Our angle is x over 2. So you times that by 2 to get the double angle, which will give you x. Well done. And Diswa, yes, that's better. Cos 2 times 10, that's cos 20. Yeah. Looking good. Okay, a few more seconds, everybody. Everyone else who's so quiet and not posting answers, I hope that you are working there alone at home and that you are checking your answers. If you are not getting something right, make sure you understand why you're not getting it right and then fixing it. Okay, that's what these lessons are about. Clearing up any confusion you might have about something and fixing it and moving forward, doing the right thing. Okay, so I'm going to call time, and here's our answers. So A is cos of 2, sine of 2 theta. B, cos of 2x. C is also cos of 2b. D is cos of 2 alpha. E is sine of 6x. F, cos of x. G, cos of 20. And then H is sine of 66, and I is cos of 42. Okay, Ntlobile, remember when you go 2 times 21, simplify it, make it 42. Question F is our angle is x over 2. So, and we recognize this as our double angle identity, one of the options that we have for cos of a double angle. Let's call up this big, where did I put it? There we go, it's here. Okay, so we recognize it's over here, 2 cos squared a minus 1. We recognize it as that identity, cos of 2a. So our angle is x over 2, so we need to times that by 2 to get our double angle. Double angle means timesing by 2. So just like we did it with the 33 in question H and the 21 in question I, we're going to take the x over 2 and times it by 2. That gives me x. So our final answer there is cos of x. So our double angle is x over 2 times 2, which gives me x. Okay. Another one for G. Okay, so G is also that's our identity. Cos squared minus sine squared. That's another option for cos of a double angle. So our double angle is 10 times 2. So we take the angle that's there, the 10, and we times by 2. That makes it 20. So, and because it is the double angle identity for cos, it's cos of 20 degrees. Okay. Then for H, so Taryn says, I'm a bit confused there by H. Does it matter on what side the cos and sine are? Does it give the same answer? No, it doesn't matter as long as you can recognize it as the 2 cos sine, that pattern, the 2 cos sine or the 2 sine cos, that is the double angle identity for sine of an angle. So we recognize that as 33 times 2 is going to be our double angle, so that's 66. So we write it as sine of 66. Okay. Rightio, good stuff, everyone. I've explained G. Let me just go through all the chats again, and I've done F. Alrighty. Okay, so that's our double angles expansions. And what we're going to do next is look at how this is asked on the Cartesian plane, where you have to draw a diagram. So the first thing you have to sort of master with this is recognizing your compound and your double angle identities and being able to expand and contract using those identities. And then the next thing is to do this on the Cartesian plane. And then we're going to do reductions, and then we're going to do identities, and then we're going to solve equations. So basically everything you've done in grade 11, all the trig you've done so far, we do it again just with compound and double angles. Okay, So reductions with compound double angles, equations, etc. All of it. Right. So how do we know, first of all? Remember, if you were here, and this is just what I want to sort of emphasize again, is at the beginning of the term we did 8 lessons where we revised all of our trigonometry. So if you weren't here for that, you're most welcome to access those recordings that are available on our website. And we did quite a thorough revision. So if trigonometry is something that you are not so good with, I really encourage you to go through the course. It's called Foundations of Trigonometry, and to work through those lessons and to do the quizzes as well, because the quizzes are still available as well on our website, so you're welcome to do that. So, and if you weren't here for that and trigonometry isn't your strength, I really encourage you to take the time to do that, because trigonometry is not going to go away. It is in your September or your August paper, and it's going to be there at the end of the year, and it is a lot of marks. It's 50 marks in your paper too, so it's a lot. So spend time on it and try and get better at it. Okay, so this is a typical question. Normally the diagram question, the Cartesian plane diagram question, is the first question on the paper. And if you've worked through past papers before, you would have recognized it. So it says if, and it always starts like this, if, and then they give a trig ratio. So if 5 tan alpha minus 12 is equal to 0, with alpha between 180 and 360, and 5 cos beta equal to minus 3 with sine beta greater than 0. Determine the value of the following trig ratios without the use of a calculator and with the aid of a diagram. Okay, so let's do this step by step. How do we draw these diagrams? You should know them as well if you were here for our big trig course that we did at the beginning of the term. But let's have a look. Okay, so we basically we have been given 2 angles. We are given alpha and beta. Now alpha and beta, immediately, now that you know about compound angles, you must start thinking. And if you glance over the questions as well, alpha plus beta, alpha minus beta, etc. The compound angles are there, and then it's sine 2 beta, cos 2 beta. So the double angles are there as well. Okay, so basically what you're going to do is you're going to draw a sketch, and you're going to use that sketch to answer the questions that are given. But let's start with this pink one, 5 tan alpha minus 12. So I wonder who can remember, if you were here for our big sort of trig revision course that we did. Our first step, I wonder who can remember the steps, but the first step is always to get the trig ratio by itself. So if it's 5 tan alpha minus 12 equal to 0, we are going to take the 12 over to the other side, the negative 12 over to the other side, to get 5 tan alpha equal to 12. And then we're going to divide by 5. So tan alpha is 12 over 5. Okay, so now we're going to draw our sketch, but we first have to decide which quadrant to draw in. So we've been given a lot of information here to determine what quadrant we're going to draw in. So first of all, what we've got here now is tan of alpha, and tan of alpha is 12 over 5, so that is positive. So now I think of my quadrants, and I say, in which quadrants will tan be positive? So that takes us back to all stations to Cape Town or cast. So tan is positive in the first quadrant and in the third quadrant. Okay. Lebucha, I'm just going to finish explaining, and then I'll give you a chance to ask your question. Okay, so we've got two options here for quadrants. Obviously, we can't draw our little triangle in both quadrants. We need to determine which of the two quadrants to draw in. So for that, we look here. It says that alpha must be between 180 and 360. So that's 90, that's 180, 270, 360. Okay, so if it is between 180 and 360 and tan is positive, that puts us in the third quadrant. Okay, so we are going to draw our little sketch, our triangle. We're going to place this rotating arm in the third quadrant. We have rotated all the way from over here where 0 degrees is, as well as 360. So we're always rotating in an anti-clockwise direction. So that is my angle alpha. And then I close up my triangle by making a 90-degree side with the x-axis, never ever with the y-axis. Okay, so I often see people do that, and that is wrong. Okay, or they go like that. Can't do that. It's always, because we are rotating, and it's with the positive x-axis. So we make our triangle with the x-axis. Okay, right, quadrants done, triangle drawn. Now we're going to place our sides. And for tan, we have the opposite and the adjacent side. So our opposite side is going to be 12, and our adjacent side is going to be 5. But we are on the Cartesian plane, so we need to take into account positives and negatives. So this is going to be -5 because it's on the negative x-axis, and this is going to be -12 because it's on the negative y-axis. Okay, first triangle for alpha, done. Okay, please give me a thumbs up or a thumbs down in the chat if you are all good with what we just did, just so we can see if everyone's understanding. Tabile says thumbs up. Well done, Tabile and Solomon, Bilwe. Awesome. Tsepiso, Cassandra and Liam. Wonderful, guys. Musichle. Awesome stuff. Okay, that is really, really good. Now we're going to do beta. And I'm gonna do beta a bit faster. No, Lehako, we can't draw in the first quadrant because we have to adhere to this here. It says that alpha has to be between 180 and 360. First quadrant is 360 to 90. So you have to draw in the third quadrant. Okay. So I'm going to speed it up a bit for the next part. And that is 5 cos beta minus 3. And I hope you are working there at home with me. You got your pen, paper ready, and you are drawing and answering the question. Maybe working ahead already as we are going. Okay, so 5 cos beta is equal to -3. We divide by the 5 to get the cos by itself. So it's -3/5. Now, cos is negative. So we need to look in which quadrants will cos be negative. Cos is negative in the second quadrant and the third quadrant. So again, we can't draw in both quadrants. We need to pick a quadrant. And for that, we use this piece of information here that says it's sine beta. At the same time as cos is negative, sine is positive. That's what this basically is saying. That means we're going to definitely draw here in the second quadrant, not in the third quadrant. Okay, and not in any other quadrant because those are the only places where cos is negative. Angus asking, do we draw For both ratios, yes. 2 triangles, one for alpha, one for beta. Okay, so let's put our arm down and then we rotate. So that's my angle beta. And drop down our perpendicular to the x-axis, make a 90-degree angle. It is the second quadrant because cos is negative. From here we can see cos is negative. It's negative 3/5. So cos is negative because of cos diagram. Cos is negative in the second and the third quadrant. We draw in the second quadrant and not in the third quadrant because the information in the question tells us that sine of beta must be greater than 0, and we know that sine is positive in the second quadrant. Okay, so you must know your quadrants really, really well and learn to interpret these things as well, the inequality sign, so that you know that that means positive or negative, whichever the case might be. Okay, so we've drawn our triangle. We need to place our sides. For cos, we have opposite, no, I'm talking nonsense, adjacent, and hypotenuse. So adjacent side is going to be -3. Drawn it a bit funny so that that is -3. And hypotenuse is 5. Okay, remember hypotenuse is always positive. Okay. Now there's one more thing we need to do for both of these triangles. Primrose, just help me please be a bit more specific. I'm not sure which part I must repeat because I've said a lot, so please just be a little bit more specific and let me know which part exactly it is that I need to repeat. Okay, so we can see for both of our triangles, the red one and the blue one, we are still missing one side. So to find that side, we are going to use Pythagoras. For those of you who know and understand, you can go ahead and do that. Oh, thank you, Ms. Coco. Primrose, Ms. Coco will answer the question in the chat for you. She'll DM you. Okay, so what are we going to do to find the side? We are going to use Pythagoras. So I'm just going to use my colors so that we can see which is which. So let's do the hypotenuse side first for the red triangle. So that is r squared is -5 squared plus -12 squared. And if you get the answer for this, please pop it in the chat for us so we can see what that is. So that's going to be, I'm just going to do it on my calculator quickly. 25 plus 144, it's 169. And then R is 13. Thanks, Sibusiso. That is 13. I agree. So let's put that there. And then the other missing side is going to be 4. I agree. We know this triangle already. It's a Pythagorean triple. But if you do want to work it out, then the y squared is 5 squared minus 3 squared. And you'll see that you get to 4. Okay. Okay, great stuff. Now we are finally at a point where we can answer some questions. Okay, so that is all the work you have to do to be able to answer this question. You have to draw two triangles. You have to place them in the correct quadrants, and you have to calculate their missing sides using Pythagoras. Okay, let's go to the first question. And I'm going to do the first question with you, and then I'm going to give you a chance to do the next question on your own. So sine of alpha plus beta. Let me just rearrange things on my screen a little bit to make some space. I'm going to do it on the side here. Okay. Sine of alpha plus beta. So for that, we go to our compound angle identity. So you have to recognize this first of all as a compound angle. It's alpha plus beta. So for sine of alpha, I use my red triangle. So it's opposite over hypotenuse, and that is negative 12 over 13. Wait, let's first maybe write the expansion before we just launch into that. Yeah, let's do that first. So the expansion of sine alpha plus beta is sine alpha cos beta plus cos alpha sine beta. Okay, so that's your starting point. And now we are going to do the ratios using our triangle. So our alpha triangle is the red one. So sine is opposite over hypotenuse. It's minus 12 over 13. Cos of beta is minus 3 over 5. And you literally just get it from your triangle. So beta is adjacent over hypotenuse. Don't get confused with the sides here. The blue side is minus 3 and 5. You could, by the way, have drawn this on two separate axes. That will work as well. Then cos of alpha is minus 5 over 13. And then sine of beta is opposite over hypotenuse, which is 4 over 5. Okay. Now, unfortunately, we can't use a calculator, so we have to do this the long way around. So we go minus 12 times minus 3 is 36. 13 times 5 is 65. And then minus 5 times 4 is going to give me minus 20. Over 65. Denominators are the same, so we can just subtract. 36 minus 20 is 16 over 65. Okay, right. Please go ahead and do question B on your own now. Going to give you about 2 minutes, and then you can, so we've done this one. We're going to do question B, and then let's do D and E. Because cos alpha plus beta is just another compound angle. I think we get enough practice with A and B doing that. Let's practice our double angles as well. Post your answer in the chat. Mohammed, 398 over 195 for question B. I need you to check that again. Don't think that is the correct one, so just double check that you got the working out correct. We cross multiply when we multiply. Well, we actually don't we can cross multiply in a fractional equation when we have like 5 over x is x over 20. We can go like that. So that's 5 times 20 is 100, x times x, like that. We can cross multiply. But if we have 5 over 10 times 10 over 2, for instance, we don't cross multiply, but we can cross cancel. So the 10 can divide into the other 10. Okay, I think Ria Rabilwe is right and Ria's right. Kirsten's right. I hope you guys aren't using calculators. Remember, it's no marks if you use calculators. 56 over 65. Excellent stuff. Well done, everybody. Then go on to question D and question E as well. Sine 2 beta and cos 2 beta. Now for cos 2 beta, you can choose any of the options. Of 3, it's up to you. Excellent. Okay. Looks like most people got question B right. You should have gone 56 over 65. Such fun numbers, don't you think, Miss Coco? 56 over 65.
Yeah, that 65 is not so nice.
Mohammed, question D is not. Please check. I think somewhere something's going wrong. Okay, so question D's answer is not that. Okay, your E is correct, Mohammed, but D needs another look. That's better. Yes, I think our answer is negative 24 over 25. Again, fun numbers. Nice numbers. Okay, good. You found your mistake. As long as you find your mistake, it's all good. Okay, so for this, we're going to again do 36 over 65. And then this is plus 20 over 65, which gives me 56 over 65. Nice. Okay, anyone got an answer? Oh yeah, you guys have been posting answers for D. So question D should be negative 24 over 25. Negative 24 over 25 for D. Because we've got sine 2 beta, and that is 2 sine beta cos beta. So we're going to just expand that to 2, 4 over 5, and minus 3 over 5. That simplifies to negative 24 over 25. And then E is cos of 2 beta. Cos of 2 beta, you can use any of the 3 options that you want. I'm going to use 2 cos squared beta minus 1. And then that gives me 2 cos squared. Now just remember, when you're squaring a trig ratio, you just take the fraction, which is for cos beta, it's minus 3 over 5. We're going to square it and subtract 1. And that's going to simplify to 18 over 25 minus 1. And that gives me minus 7 over 20. Okay. Right. Wow. Well done, everyone. That was quite a long question. I did have a few more planned for us today, but it is time for our quiz. So feel free to, yes, Ms. Gaga, phew. Feel free to take a screenshot of the questions that we didn't get around to, and you're welcome to practice them in your own time. I'm just going to move them up into one spot and then you can take a screenshot. Yeah, they're normally not that long in the exam, but you do get these where you have to draw two diagrams. Okay, excellent work, everybody.
Tanya, I got the link to the quiz in the chat. Remember, guys, that if you can't get onto the link doesn't work, you can just log back into watobe.co.za and you'll find the button for the quiz as well. And I think that's it from us today. Hey, Miss Marlies.
That is it. Well done, everyone. Remember, you don't have to stay on the Zoom call to do your quiz. You can just log off from Zoom and go onto the website, but you do have to be logged into our website to be able to do the quiz. And yeah, then we'll see you back here next Tuesday. Have a good week and stay warm and safe, everyone.
Bye, everyone.